surveying PEG 4.2, and please off call it your we call it your speaker, and we are going back to do our normal business about how we want to proceed. The last chapter is traversing. We keep it at chapter 3 at the last because it's quite complicated, but no problem. Tomorrow you have a test, and you must master all about the chapter 3 because most of the question normally is for the chapter 3. Then I think chapter 1, chapter 2, you have no problem because you have basics, fundamental, you are very strong about ignorant survey. And we call it tomorrow at 9 until 11 of time, I have a revision class. So don't worry if you don't catch this class tonight. So we call it, we are surface for we serve for 20 slides tonight. And if you don't understand, tomorrow you will again can ask me because I will do the revision based on your, we call it based on your questions. Okay, right? So coming back to our business, I want to present the topic today. All right. So we share my, we call it my screen. Okay. All right. Can you see my screen? Clear?
Yeah, clear, Doctor.
All right.
Clear.
So we are going for example 4.4 where we're using a theodolite. And theodolite, you already use it. And then you still remember we call it doing something like practical at Laman Perdana of UiTM Pulau Pinang. And maybe you remember when I asked you about you must set up face left and face right. Okay, and we set up, we call it face left and face right when we are measuring a one line. For example, that from one, for example, that from station A to station B, right? So what you do is you are doing something like you are measuring one station, but you are measuring face left and face right. You still remember that you rotate your telescope? Do you still remember that you rotate from left to right of your two arms of the theodolite column? Maybe you remember that. Okay. So here we have a station A to D. We are measuring twice. First is face left, second is face right. So face left is 60 degree, 45 minutes, 40 seconds. Meanwhile, for the face right is 246 degree, 45 minutes, and 0 second. And we measure using a tape is a 40 meter in distance. All right. So you still occupy. You not move your equipment. Still occupy at A. You observe at point B, and you get the face left 162 degree, 20 minutes, 20 seconds. And you rotate, we call it your telescope, again from A to B, 342 degree, 20 minutes, 20 seconds. Okay, so you are measuring by using tape. The distance from A to B is 36.0 meter. So this exercise, we are repeating. We move the equipment to B, we observe to A, D the reading for, we call it left, is reading for right. And we not move. We are rotating our telescope from B to A to B to C. So you get this reading for the face right, 22 degree, 41 minutes. Meanwhile, for face right is 202 degree, 20 minutes, 20 seconds. Okay, again, we are move our equipment to C. We are doing the observation from C to B, C to D, and we have face right, and then we have face left. Okay, we move the equipment to point D, and we observe at point C, we observe point D. D is the reading for left, D is the reading for right, this is reading for left, this is reading for right. And some basic principle here, when you have right A to D, you have face left and face right. So these different must be 180 degree because this one in one station. And this is the data about the distance from, we call it B to A. So the distance is around 36.0 meter. B to C 37, C to B 37 because it's the same, right? This one is same. Okay, this one is same. CD and DC, same. And D to A, 40 meter, we are measuring by using tape, right? So example 4.4, D is the work. So what is the database? So what is we call it instruction? Database site was obtained by a group of students during a closed travel surveying using satellite. Closed travel you mean that you can assume this one point A, B, C, and coming back to D. So this one again, I repeat, A, B, C, and D. D is the data. And D is our sketch, or we call it diagram. Right? Correct. Okay, right. Find the correct bearing if the traverse work was done by mean bearing method. So we are learn about the red color mean bearing method. So sometimes we call it MBM. Alright. So we move for the solutions. Okay. This one is the question. Now the page we call it the slide 18. So how we want to make it solution for the MBM. You still remember the MBM? Okay. Mean bearing method. Alright. So first, calculate mean bearing for face left for each line. So first. Second, compare last mean bearing face left with the first bearing face right. Okay. Example, error divided into number of section. Okay. So that is, we call it how we calculate from station A, find mean bearing, okay, A to B. Okay, A to B for face left. Okay, so face left, you have this one. Remember that 162 degree 20 minute 20 second, we plus with in bracket 342 degree 21 minute 20 second minus 880 degree 0 minute 0 second. Why we minus 180 degree 0 minute 0 second? Because we want to know from 342 degree 21 minute 20 second is minus 180 degree 0 minute 0 second. Of course, it will give answer. But normally the answer must be same like this one. But in theory, yes. In practical, you cannot get it. You cannot get it. So when we do the average, we are divided by 2. Okay, we are divided by 2. And we are doing a plus, here plus, face right, 342 degree, 20 minute, 20 second, minus 180 degree, plus 162 degree, 20 minute, 20 second. It's something like you are, we call it, this one is second data. So first, face left, face right. So D is, we call it face left section. This one is the face right section. So both we are doing, we call it a mean. We call it mean because we divided by 2. And after we get this reading, again we plus here, and then again we divide by 2. Because this one is mean bearing. Mean that normally we give a middle value about 2 reading or 3 reading or 4 reading. We make it average actually. So means you are doing the average of number sample or the number of reading. Okay, so you get 162 degree 20 minute 50 second. And if you are going back to the slide 79, so the reading we get it from here. So all the reading kita dapat di sini, we get it from here. For example, that this one. So try to help you prepare this one. So first we wrap because we want to make it easy. Okay, even though the wrapping take times, but it gives you a clear understanding about this one. So again, you are going back to this. I think you understand this one. I'm going to wrap again. So this one also we try to wrap. We try to erase it. So now we want to detect where all this data we get it. Okay, so first we investigate this data. 162 degree, 20 minute, 20 second. You remember that? Face left. 162, 20, 20. Okay, 162, 20, 20. Here we are. A to B, this one. Okay, then we're going back to this. Okay, so now you get, where you get 300, 342 degree, 21, 20 second. 342, 21, 20. So you're going back. This one, eh? So you get this one. 342, 21, 20, eh? So you get face left. The data, eh? From A to B, B to A, actually in one line. If you want to calculate face right using this data, okay, A to B 342 degree 20 minute 20 second, B to A 162 degree 21 minute 20 second. If you are minus, for example, that face right, face left, when you are minus like this one, AB, face left, you plus with 180 degree because this one is less than 180 degree. So you get, it should be, you get this value. But unluckily on site we cannot get it. We cannot get it. For example, that 342 degree, you plus with 180 degree, it should be supposed you get this value. But on real situation, you cannot get it. So you make it average value. I think you understand this one. So you get 160 degree 20 minutes 50 seconds. And if you look at line, this one AB, you look at line AC. So you compare AC like this. Eh? So we take all this data, we are doing something like this data. So we fill up this one, we put this one, we put this one, we put this one, and we average all the data, and again we average again. You get 286 degree, 22 minute, 40 second. Then compare first bearing AE face right with last bearing EA, mean face left equal to 245 degree 45 minute minus 246 degree 45 50 minute. So it's equal to your error 0 degree 0 minute 50 seconds. So in Thermolite, normally our error, we are not going to sometime degree. Mean that you cannot say that your error is 10 degree. But if you put 10 degree, the people will laughing to you because the Thermolite give you the high accuracy. Normally, maybe 1 degree, 2 degree or less than that. Maybe we call it a minute or in second. So because of we have error, 0 degree, 0 minute, 50 seconds, so we take this one, put it here. We divide it by 4 because we have 4 stations. How you know? Remember that A to B, B to C, C to D. Because the exercise have 4 stations. So every station you must minus, minus 0 degree, 0 second, 0 degree, 0 minute, 3.75 second. Okay, so here, so actually when we have something like this one we get it from our side. And this is, we call it the reading from mean bearing. So because of this one, we want to make sure that 246 degree, 45 minute, 50 second. This one is 0 second. This one 50. So when we minus, so we get 15 second. So 50 second divided by 4 because we have 1, 2, 3, 4 stations. So every station we are doing corrections about mean bearing. Okay, so you are minus 0 degree, 0 minute, 3.75 second. Very few. So you get new one. So if you compare, you can get the differential is a minus 0 degree, 0 second, 3.75, 0 degree, 0 minute, 3.75 second. Okay, for example, also, we are doing some subtraction, so you get 22 degree, 30 minute, 37.5 second, and this one 286 degree, 22 minute, 40 second. You minus with 0 degree, 0 minute, 11.25. Okay, you minus and then you get this value. And lastly, you minus with 0 degree, 0 minute, 50 second. So you get 246 degree, 45 second. Okay, my question is, why you get this one? This value is from this calculation. You remember this calculation? This calculation. So I just show you two. Actually, we call it, it should be, the answer is for A to B, B to C, C to D, okay, and D to A. So we have 4 lines because it's comprised of 4 stations. Okay, I think it's okay. This one is mean bearing method. Another one, we have coordinate or the Bodish method. And you must know every method here because your questions will be asked to cover all the chapter 3. Okay, how the coordinate Bodish method? Okay, again, why we do this? Because again, the Thermalite cannot give you a perfect answer. You only, we call it, read the data on ground, and normally we going back to office to do analysis. So when we do analysis using the, you still remember compass, include angle method, and now you remember that MBM, mean bearing method. Now we go for the third one, we call it coordinate or Bodish method. This method is to correct your traversing your angle based on theoretical parts. And of course, normally students, they love going to field. They are very happy to handle with equipment. They get the data, but they don't process. So sometimes they not submit the assignment. So they cannot submit, we call it, they don't want to submit, we call it the lab report. This is, we call it, give me a very, very sad. You know why? Because you not have a complete circle about knowledge. So when we dealing with the civil engineering, you must know, actually, you are different. The governments, or we call it the private sector, will pay you more higher salary because you can analyze. So every subject, you must know that 4W1H, what, when, still remember that, why, and who, and H is how. So you are more on we call it 4W in the third one. So why? So you always say why? Because when you say why, it's coming back to the Bloom taxonomy. We call it, you are trying to analyze, you compare it, and you search for the answer. So at, we call it your blue collar, the people call you engineer, you must always analyze your data. So student normally they come and just play around with the equipment, get the data and they throw away the data, they not process it. If you not process, you are just certification. You just have a certified or certificate from the civil engineering. Alright, so the introduction about coordinate or bodice method. This method assumes that the error in the bearing of the line is due to some accuracy in angular or line measurement, give a displacement of end of that lines relative to the other and equal at the right angle to the displacement. So that is, we call it the definition about coordinate or the bodice method. Okay, so step to calculate. Normally we use words, we call it the whole circle bearing. We don't use quadrant bearing. You know why? Quadrant bearing is quite tough when you are have a data and to transform based on the complicated system. And the whole circle bearing normally we call it for a compass. You using for the total station and then for the theodolite. So WCB, still remember, we call it whole circle bearing. Alright, calculate the latitude and depart. So latitude and depart, something like you should still remember that you learn in the school, you have the coordinate graph, paper graph. Still remember paper graph? So this one is 0, 0, this one is 1, 1, this one is 2, 2, this one is 3, 3. Okay, for example, so 0, 0, this one 1, 1, this one is 2, 2, this one is 3, 3. If your point here, of course you know that 0, 1. So the coordinate something like, you have the point like this. You have this station 0, 0. You have 0, 2. So you have here 2, 2. And then you have 2, 0. So when you connect, is from the traversing. So this is, we call it coordinate system. But actually this coordinate system, I should explain to you more. But we call it, I think that we don't have times to introduce you about more deep the latitude in the part. But I will show you the system is like the graph paper. Okay. Calculate the total latitude and departure. Calculate adjustment and eliminate of discrepancy. And don't worry, we show you a bit about this process. So there is a page, next page, Latin and part. Very sorry for this one. Okay, if you look at this system, if you look at this system, I think, okay, right. So we have actually a two point A and B. All right. So this A and B, when we relate based on bearing, angle, and length. So bearing, we're using a compass, we're using a total station or theodolite. So length, we're using a, we call it chain survey, chain survey, using a tape, and then we're using a laser or radio frequency, radio wave. Okay, length. But point A and point B also, you can measure by coordinate. For example, this coordinate. So latitudes and departure. Okay. So we call it latitude and depart in bahasa. Latitude and departure, L and D. So this point maybe latitude is 1. we call it 100. Departure also 100. Maybe point B is 200, 200. So you have, we call it delta y, delta x, the difference between 2 points. From this delta, you also can calculate about the angle and length. And depart follow x-axis, departure, and latitude follow y-axis. And this y-axis normally we consider n north, and east we consider in the departure. Alright? So that is, we call it the system of latitude and depart. And then hopefully that's we coming to this. Next we call it slide. Okay. You also can have this one, right? Okay, this is also show you about how we call it northing and easting, or we call it latitude and depart. Departure normally consider about easting, east. Going to draw, so departure is easting. Latitude is a northing. Okay, all right. So here again, they will call it explain about the angles from north, and then again about we call it this length. So from this angle and length, we can assume the latitude or northing, and we also can know this. We call it distance based on departure or easting. And there's another one. If you look at this one also, the same fundamental or concept. Let me recall it erase first. Yeah. So if you get at this one also we call it it was something like departure and latitude, but the bearing is here. The bearing is different because it's going down. Okay, the same concept. So departure and latitude. This one easting, this one northing. We have this angle, and we have this distance t. Right? We go slide number 88. Okay, number one. Closure of a traverse is checked by computing latitudes and departure. Latitude of a line is its projection on the north to south meridians. I already told you this one. And the line is equal its length times the cosines of the bearing. This one cos. So normally cosinus we consider cos. So if you want to calculate latitude, you have L, horizontal distance, times by cos 30. For example, like this. You have a 45 degree and the length is 100 meters. So to get it, latitude coordinate, latitude is equal to L times cos theta. So L is 100 times cos is cos. So your angle is 45 degree 0 minute 0 second. So this is how you want to calculate about latitude, northing to southing directions. This direction, northing to southing. So for the vertical, we are using this formula. And for this formula, using L sine theta. What is the formula? L sine theta is from west to south. All right. Okay, this one is already explained. That's good. And this is the example. If you will call it understand about this one. Okay, all right. So what is it? So you have north. Okay, of course you have this one is south, and this one we call it east and west, east and west, and we have the angle of this one north 29 degree 53 east, for example, right? If this one, this angle like this is the angle, right? So from D to A, the distance is this one, 63.642 meter. When you transform this one, is something like this, using L cos theta, L sin theta, so you get D to A for nothing and listing. Okay, so you get it 55.180 meter. Meanwhile, for this one, okay, this one latitude, L. This one, when this one latitude, this one departure. Okay, so L cos theta, L sin theta. So this one cos, this one sin. L cos theta. What is the angle? This angle. Take it this angle. Put it here. So you get this answer. 31.709 meter. Okay. So I think you can see this concept also. How we call it, normally we're using a bearing A to B, for example, from north. Okay. Maybe 45 degree. B to A. Maybe this one is something like, excuse me, something like 100 degree 20 minutes. A to D, maybe it has more than 180 degree. This one maybe 190 degree, for example. Maybe C to D. So C to D, maybe you can get less than this one is maybe the 70 degree. So you just recall it, for example, no. C to B maybe is 35 degree. So we just using the angle and distance. But when you are calculating latitude and departure, you can see that they make it square box here. Something like a grid, okay? So they calculate every vertex. This one, this one, this one, this one, this one, this one, and this one. So the same works, but we're using two type of system to identify the station C, A, B, C, and D. Alright. Very sorry. Okay, in latitude and departs, normally when you calculate, you must be aware of this one. If your traversing is here, it's different with the traversing here. Even though the same, you must know about the where is the quadrant of your we call it traversing. Is it in quadrant 1, quadrant 2, quadrant 3, quadrant 4? Because when the quadrant 1, normally we consider latitude and depart. Is latitude is cos angle is positive, and for departure at this quadrant 1 is sine angle is positive. No problem. You still remember that you learned the coordinate 0, 0, -1, -2. You still remember that in your school? This one we consider 0, -1, -2, right? So this is the same. They also had a quadrant. When we put all this quadrant like this, for the third quadrant, all -1. Okay, but we put in the quadrant number 2, just latitude positive, departure negative, latitude negative, depart positive. When we put in the quadrant 4, you can see that it's opposite direction. So this one actually is opposite, So we opposite. So when we call it latitude is a positive, and we call it departure is a negative. So this one also opposed. 2 positive, this one 2 negative. So it's easy to remember. So D is the system of latitude and depart. All right. We already finished. Now we're going to 92, slide 92. So adjustment for every line must be done. So with that, after we calculate the latitudes, and then we must do, we call it the adjustment. Line correction divided by adjustment is equal to discrepancy divided by total length. Discrepancy means that the error. Discrepancy means that's error. And error come from the equipments, maybe come from you, maybe come from the weather, from the lecture one. Time by total length. For example, at total length, you have a station A to station B, B to C, C to D. For example, this length is 100 meter. This length is 50 meter. This length is 110 meter. This one is a 40 meter. For example, so you plus 100 plus 50 plus 110, you plus this 40. So you get the total of this one. This total is the total length of the traversing. Time the length of the line. Total length and the length of the line. Okay. Alright. So when you want to calculate about latitude, so L cos theta, and for the part is L sin theta. So that is different. And latitude is to remember that north to south. Departure is like this. West to east. Okay, so west to east, you calculate sine theta. North to east is a cos theta. All right. Okay, we finish at slide number 22. All right, we are going to error of closure or misclosure. Don't worry, after this, we have example, we can see it's very easy. Error of closure or misclosure, this one is something like sometimes you call it error is discrepancy. Discrepancy. When doing a close travel survey, a surveyor walks as far as north as him her walk the same distance to the south. This is applied also to the east and west direction. In this situation, the sum of latitude and departure should be the same or equal to 0. Alright? So we go to slide 94. In reality, the sum of the two will never be exactly equal to 0 in reality. When latitude are added together and depart also the same thing, the resulting error is referred as error in latitudes and error in departure. E is the symbol. E is error. E is error. L is latitude. D is departure. Right? So like 95. Okay, so that is we call it after we are doing survey, sometimes you have error at this part, last part. So we call it e-closure, error disclosure. So that's one is the coordinate, according to a coordinate, error in departure and error in latitudes. For example, in this figure below a scale drawing a closed travel survey, the figure will not close because EL and ED. Yeah, delta, we call it error, latitude, and error departure is, we call it not connected, right? Okay, the formula to correct this error as a follow. So we want to avoid this one. You don't want this, so you must do this formula. So the formula to correct this error are the follow. Error of closure, E closure equal to square root of EL power of 2 plus error in departure square root. This one for the error of disclosure. After we calculate the error, we calculate the precision of measurement. This precision will determine either your work going to first class or the second class or the third class. So precision is equal to E closure. That's why you must calculate this one first. This one first. You take this reading, put here, E closure, divided by total length of the traversing. So you get precision. So first calculate this one. After that, you can calculate the precision. First calculate the error. Okay, this is the example to give you, we call it a better clear about our exercise or what we are mentioned and give you a theory is something like this. Example 2.6. I think the last one should be happy because we the end of this class. Giving in a bearing for a traverse compass survey conducted by a group of students. Find the coordinate for the each point by Bowditch method. Okay, so it's a very long journey. We are going to Bowditch methods. What is the theory? And then we learn Latin and new part. Now we can give example in this teaching technique. So A, B, B, C, C, E, E, G, G, J, J, L, L, A is something like in a compulsory we call it forward bearing or forward bearing. And this is the distance AB 103.4, BC 157.25. So they're using a watts, using a tapes to measure the distance from A to B. For example, this one A is going to B. So the whole sector bearing is 187. So if you have this one 0, this one is 90, this one 180, this one 270. So 187, where is it? Something like this one. Okay, you get this point. What point? This one A, this one B. So the distance is 103.4. 103.4. And 103.4 is measured from A to B using a what? Tape or maybe radio wave or maybe laser, okay, or we call it change, right? But if using a tape or using a change, the accuracy you get it is very low. But if using, we call it a laser, a radio wave, radio frequency, so you can get all your calculation is going to the first class order in survey, right? So for this one, I should erase first. I think you can get the point. What is the table means? Okay. Okay, right. That's good. So again, that's we are going to BC. I'm going to draw. I'm going to touch BC. So this is the distance. This one the whole circle bearing. Okay. So now what's next? What we call it? We should do after this, eh? Okay. Okay. So you can see that this is we call it example that's a bearing, eh? Wait, so you can see this one for A and B. A and B, I'm going to draw A and B. The bearing is 187:22 minutes 20 seconds. Okay, look at this one. 187:22:20. So we call it going to next. So here, 187. Here, 187, 22 minutes, 20 seconds. And that is, we call it the distance. Okay, you still remember the distance? How they measure the distance? They're using what? Tape, change, laser, or radio frequency. So they calculate. You still remember that L cos theta, L sin theta, still remember? So they're using this one. So latitude get negative 102.5452. Whereas for another one, departure, L sin theta, this one, you get negative 30 degree, 30 degree 0.2678. All right. So you calculate for point A, for point B, C, D, E, F, G, and L using this formula. So you have this formula, right? To get all the value here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Alright? So after you get this one, what you do? You total the distance. You total up here. You get this value. And here also you total up. Negative plus negative plus negative plus positive, 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 positive. You get this value. And you also use sum up here. You get this one. So you see that here is the error. What the error? The error of latitude is negative 0.1537 and the error for departure is positive 0.0589. And they do the corrections using latitude and depart. Okay, so they do the corrections. So when they have this correction, again, they can get the, after we call it, they do corrections, so they still have, we call it error. So again, they're doing a balance. You get this one, this value. So they plus again, so you get 0, 0, balance. So if you get 0, 0, station A, for example, the X, or we call it sting. So remember sting? Okay, sting what? L sin theta, right? 1000. Y, nothing. L cos theta. So from here, they calculate about the B coordinate. Get this one. They get C coordinate. Get this one. Okay, they get A, B, C, D. Should be D, eh? D coordinate. You get this one. And then you get this one, we call it J. It's okay, no problem. And until you get J, K, and L. So this one, the right is sting and nodding. So when you plus this one, you can get backs, going backs, A to A, L to A. Alright, so you get 1000, 1000 is same like this. From A to B, and lastly you can get L to A, because A you start 1000, A you start with 1000, 1000, A you start with 1000 and 1000, and coming back to A is 1000, 1000. That means this exercise is finished. How you are doing a Borish method to solve this one using the coordinate system. Okay, still remember that? Latitude and departure, nodding sting. And based on this, I should write first. I don't know how we call it. Okay, for example, that's it's okay. Let me try to change the color. and we draw. For example, that you have, we call it this one, 1000, 1000. Again, we're going to draw. Okay, 1000, 1000, rotation A. So when this graph, you go to 1000 to 1000. So 1000 here, and this one also 1000. So you plot at this point. This one is point A, right? Then we are going to point, we call it point B. Point B. So I put it at 900, 900, 1000 because I take it nearby. So 900 and 1000. Where is it? 900, 900. Wait a minute. Where is X? Where is Y? So your X is 900. So remember that your X is equal to 900. Actually, it's
Doktor dia apa?
Asal tu line Aku tengok dia orang punya.
Ui, aku punya line pun teruk ni.
Aku pun
Banyak tinggal ni.
dengar macam tak apa nak clear dah.
Assalamualaikum. Assalamualaikum.
Aduh,
Salam Afiq.
banyak kali kita keluar.
Ya, perhati saya yang left masuk, left masuk, left masuk.
Pakai Selcom apa?
Mobile.
Tapi tadi kiraan dah habis kan sebab tengok last tadi kepada dapat apa yang close error. Yelah kot. Ni Afiq dah okey Afiq,
Duh,
mic dah okey
kena minta doktor recording. Banyak tinggal.
PE left. PE pun left.
Aduh.
Cakap lah Afiq asal senyap je. Apa asal
Cakap pun apa sekat-sekat.
Assalamualaikum.
Salam.
Salam.
Ya, awak ada cakap.
Tak
Hello semua.
kuat lah tu.
Ni memang lain semua orang lambat ke hari ni.
Soal laptop tu. Siapa ambil static?
Pak semua minta record video.
Share.
Kena tengok balik.
Siapa nak dengar aku nyanyi? Aku nak nyanyi lah.
Line tengah tak okey.
Weh Afiq, hang pakai line apa
tak
Afiq?
payah.
Aku nak payung satu lagu.
Pakai line apa Afiq?
Tak payah.
Senyap. Daripada itu tak ada dengar suara dia pasal.
Boleh lah.
Doktor tak ada ni nyanyi.
Tengah rekod tu.
Ya.
Eric dia ahli kan? Tu dia tak join kan?
Luar
Kenapa
sial
rekod
dia.
ni?
Doktor tak masuk balik ke?
Dia PE nak cakap apa tu PE?
Nurin,
Apa?
cepatlah present.
Esok kan quiz. Esok quiz kan
Weh.
weh. Esok kan.
Bahaya. Sekejap Macam nak present
Awal lah
Lupa
Nurin.
Cepat present.
Awal lah Nurin nanti lah.
Prison slide.
Cepat Azam.
Lah, aku tak tahu. Sangkut je aku.
Kantor je.
Masa belah banyak sangkut lah. Sebab
Haa.
aku punya bar naik 4 pula. Macam tengah
Ui,
hari.
kena ni lah. Kena
Dia je
remind doktor nak recorded.
5 balik
Siang
gila.
tadi pun kau ada sangkut juga.
5 balik gila sikit kot. Dia kena sekejap. Tapi kadang-kadang aku ubah dekat yang Nuri Zealand.
Penatnya
Amboi.
aku.
Apa je? Adalah.
Mas,
Afiq buka kamera. Confident.
Jom buka.
Segan.
Payung sikit.
Apa?
Payung sikit muka.
Ish, tak apalah.
Doktor boleh masuk balik tak ni?
Boleh je masuk. Tapi masalahnya
Lain dia kot.
line dia tak okey. Sebab tadi dia pakai dia punya laptop kan. Tab. Sebab dia kata laptop dia host.
Tak, tadi kan yang berapa banyak kali sangkut tu sebab lain doktor ke lain aku lah. Aku rasa macam sangkut-sangkut.
Aku dengar suara doktor macam macam tu, rasa tu line.
Tapi aku terkeluar lepas tu. Aku tengok
Ya,
ni pun
kenapa
satu
kau
bar je.
terkeluar? Aku tengok ramai asyik terkeluar macam.
Tahu aku waktu dia ajar yang kiraan tu kan. Tiba-tiba lain sangkut. Lepas tu masuk balik dah habis dah.
Ya doh, sama.
Aku macam, weh, apa benda? Macam mana nak jawab besok?
Weh, aku macam tak boleh cakap dalam ni. Okey lah, malam. Tengah record.
mesti esok 9 sampai pukul 2.
Kita jam.
Amboi.
2 jam. Masa aku quiz 2 jam kan. Sejam je.
Lepas habis solat Jumaat kan terus lari pergi laptop.
Esok
Pukul
kulit.
2 tu buat.
Detik.
Pukul 2 ke 3?
3 kan.
Esok nak kena set
Dah
console. Practical test. Geosol.
3 test. Dapat apa Fik?
Aku dapat sendiri placement. Dapat Roger.
Apa? Send investment?
Ya.
Syamu lah.
Cantik.
Dapat JKR weh. Sumpah. JKR kat TikTok.
Ni
JKR.
test apa ni?
Aku dapat.
Geotek.
Oh, je.
Kami kena buat
Azim dapat apa
video.
ni? Azim dapat apa?
Siapa?
Azim?
Rin dapat apa Rin?
Aku dapat JKR.
Siapa dapat JKR?
Tu
Aku.
Azim.
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 Ha.
Jom lah.
Yo.
Masih bersama.
Afiq, Roger Fik.
Aku nak
Dalika buat apa?
Buat
Pasir tak boleh tu. Sini musim hujan. Pasir basah.
Tak, aku pakai beras.
Oh, lu beras mahal. Membazir.
Pakai balik lah. Bukan kotor pun beras tu.
Memang lah tapi macam tu.
Betul lah.
Tapi
Cuci juga beras tu.
kau kena beras basmati ke? Sikit.
Kan? Mention sikit.
Baru
Lalu
nampak. Apa?
Assalamualaikum.
Kesalam doktor.
Waalaikumsalam doktor.
Putus slide nombor berapa?
Nama
Pasti. Slide nombor berapa putus?
Kenapa doktor? Line ke?
98 doktor.
Like yang 3 terakhir tu.
98.
Ya Allah. Ya. Saya rancak je mengajar.
99.
Dugaan
90?
dugaan last minute.
99.
Keinginan ni saya cuba sambung Subhanallah. Apa ni data phone.
Kenapa?
Ya Allah. Okay, still record is okay. Notes. I go to present now. Your entire screen. You go to share. Line Satcom tak berbagus sekarang ni.
Ya doktor. Saya pun sama. Satu bar.
Oh. Saya memang kat rumah handphone semua pakai line Satcom. Okay, slide number 98 ni.
yang ni.
Yang ni 98.
Oh, sampai kat mana tah? 98 sampai
Selepas
kat
ni
mana?
kot, rasa selepas ni.
69.
Yang gambar tu, 99.
99.
Yang plot tu.
99. Okay.
Ini.
Because this is a plot traverse is something like your graph paper. You still remember that your latitude for station A and departure station A calculation. We're going back to this one. 1000, 1000. Still remember that? X and Y, right? Okay, so you plot 1000 to 1000. 1000 and 1000. So there is the point. Okay, point number 2, this one. You get it? We plot. Now we're coming back to station B. Station B, D is this one. So 897,471. So I put it not 800. I say this 900. So 900 in X, 900 is an egg, or we call it easting. Egg or easting. And for Y is 986. I consider 1000. So Y is a 1000. So there is nodding. Okay. So when we back to this graph, okay. So first we search for that one is 1000, 1000, right? Like this, 1000, 1000. And the second one is X 900. Where is X? 900x, 900, 1900. Okay, X, Sorry. This one. So 900. Okay, we're going to 900, this point, and 1000, this point. So this point, like this. So this one is point A, this one point B. So we connect with one line, alright? So we are we call it a green color to connect this. So A and B, like this. So you get it? So we plot based on coordinate, plot traverse in a graph paper. Okay. And this is to exercise 4.1, exercise 4.2. So you can do exercise. And of course, you try to, we call it, a recap about this one. L sine theta, L cos theta, like in the part, so this part, and then how we do this correction and balance. You can see this in the note here on top. You can see this one. How we calculate is closure, how we calculate the precisions. So why this one is error in L and error in distance, error in departure and latitude. And we use this formula, error in latitude and error of departure. Come back, it should be 0. Is the best one. And the discrepancy, so divided by total length and time by length of line. So you get it L cos theta and sin theta. And we call it this system. And after that, you calculate all this one using D is the result. And D is the plotting of the graph paper. Right? And you finish. Okay, thank you everybody. Hopefully that you can review this one. You can study. Then from that, maybe we give you, we call it review example. Before we are going to do a test on tomorrow evening. All right.
Alright, Doctor.
Okay. Thank you.
Doktor.
Okay,
Thank you,
doktor.
doktor.
Thank you,
Um,
doktor.
Doktor.
Thank you, doktor.
Doktor, doa kita good luck besok.